This video is an overview of the requirements and specifications for sub-base and base course aggregates. The following videos will explore the specification testing in more detail. The sub-base and base course in most flexible roads are unbound aggregate layers. Aggregate is a mix of separate gravel and sand particles. Unbound means that the aggregate particles are not cemented or otherwise stuck together. Unbound aggregate layers rely on the interlocking of the various aggregate particles for their strength. The separate aggregate particles and the mix of the aggregate particles need to have a number of properties to enable the aggregate layer to support and distribute the road loadings. Roads need to provide a smooth, safe running surface for decades with minimal maintenance, so the aggregate layer and the particles that make up the aggregate layer need to maintain their properties over long periods of time. The properties of both the whole mix and the individual particles is important. Important properties of the whole aggregate mix are its grading, which is the mix of the different particle sizes, and the strength of the compacted aggregate layer, which is measured by the California bearing ratio, or CBR. The coarse materials in the aggregate mix need to be angular, be able to withstand the loads on them without crushing, and be able to withstand erosion by weather forces such as rain, running water and wind. The finest proportion of the aggregate mix cannot have too much silt or clay. The proportions of these materials is measured by the sand equivalent and plasticity index tests. Granular layers and the materials used in them need to be tested to demonstrate compliance with these requirements. The required testing and acceptable results are set out in the specification. One of the most useful sets of specifications relating to roading produced by the NZTA, formerly Transit New Zealand. The NZTA are responsible for designing, constructing and maintaining all state highways in New Zealand. To do this, they have developed a series of specifications that cover all of the works and materials involved in roading. In this video we will look at the NZTA specification which apply to state highways and which most councils use. However, it should be noted that some councils may have different requirements for their roads, but these are usually still pretty close to the NZTA requirements. Having said that, NZTA has no specification for sub-base materials, although there is a set of notes providing guidance on the requirements for sub-base materials. These notes are titled TNZ M3, Notes on Sub-Base Aggregate Specification, TNZ M3. This document sets out what a sub-base specification should include and sets out the minimum requirements. However, it does not provide the details required to define the sub-base properties. This is left up to the local councils to define the sub-base specifications for their area. This is done because the types of rock that can be used to produce sub-base vary considerably around New Zealand, and one specification would not allow the flexibility required to enable local materials to be used. The requirements suggested in the notes are similar to those included in the NZTA base course specification M4, which we will look at now. NZTA does produce a specification for base course materials, which has been adopted by most roading authorities in New Zealand. This specification is called TNZ M4, Specification for Base Course Aggregate. There is also a set of notes providing clarification and elaboration of the requirements set out in M4. Copies of these documents are included on the topic page on Moodle. Section 1 of TNZ M4 is one sentence setting out the scope of the specification, which is to set out the requirements for base course aggregate. Most specifications start this way with a statement setting out what they cover, that is, what their scope is. Section 2 of TNZ M4 is the general requirements. The main requirement being that all sampling and testing is done by an IANZ accredited laboratory. That means that the laboratory has the equipment and skills required to undertake the testing as required by the specification. IANZ are the government organisation tasked with checking this. These tests need to be carried out using specific procedures, most of which are set out in NZS 4407-2015, Methods of Sampling and Testing Road Aggregate. This document provides a detailed description of the steps required to carry out each test, so everyone does the test in exactly the same way. This means that the results of the testing on specific materials provide an accurate indication of its properties and allow designers and road controlling authorities to set out specific requirements based on those tests and have confidence that the road will perform as designed. NZS 4407 is produced by Standards New Zealand, who are a government organisation dedicated to providing standards for all New Zealand industry. They produce hundreds of standards ranging from detailed description of the requirements of steel bolts through to contract agreements through to laboratory testing. Standards significantly reduce the amount of work required to practice engineering and ensure that what we produce will do what they are supposed to. They are usually identified by NZS or AS-NZS prefix. The AS-NZS standards jointly shared between New Zealand and Australia. You don't need to access this standard if you do not have it available. However, most companies do have some copies, and it's worth having a look at if you can, but it's not really necessary for this course. If you're working in a laboratory, the standard is very important, but otherwise you just need to know what the tests are and what the requirements are. Section 3 of TNZM4 specifies the requirements of the source material. The source material is the rock from which the aggregate is produced, and the tests required by this section determine the properties of the rock material itself. Road aggregate is produced in a quarry, which quarries the rock, crushes it, screens it into sizes, and then mixes or blends the aggregate into the required mix of coarse and fine particles. This photo shows is a photo of an overseas quarry. You can see the quarry face in the background where the rock is removed from. In the foreground is a machine which crushes the rock and sorts it into different sizes using screens. The different sizes are then blended to form the BASECOURSE aggregate. The aggregate particles need to be made of hard sound material free of soft or other materials that would prevent the aggregate from supporting the road loadings without breaking up or being crushed. The material also needs to be able to maintain its hardness even after decades of exposure to the elements. Therefore, the tests in this section relate to the crushing resistance and the strength of the material, as well as how well it resists weathering. This section also sets out the amount of testing required. If the rock being quarried changes, then a new test needs to be done, or a new series of tests need to be done. However, if there is no change in the rock, then tests still need to be done, only one sample for every 10,000 cubic metres of rock quarried. Section 4 of TNZM4 sets out the requirements in regard to the production properties of the aggregate, that is, the quality of the aggregate mix. The main test is the grading of the aggregate, that is, the proportions of the different sizes of sands and gravels that make up the aggregate. Another set of tests relate to the clays and other fine materials in the mix. There will be some fine materials in the aggregate, but too much can reduce the strength of the final BASECOURSE by trapping water in the voids in the aggregate and lubricating the contact points between the aggregate particles. You will recall that BASECOURSE relies on the contact areas between particles to transfer and distribute the road loads, and anything that reduces the effectiveness of these contacts will result in the BASECOURSE layer not being as strong as it should be. The specification requires that aggregate particles be broken or crushed, as we need angular particles to maximise the contact areas between the aggregate particles in the BASECOURSE. Rounded particles that have small contact areas, resulting in the load being concentrated and an increased risk of the particles crushing, as shown in the diagram to the right. Therefore, the specification requires aggregate particles to have angular faces. This section also sets out the requirements for sampling. Aggregate is usually sorted into lots of similar material. It is inaccurate to test just one sample, so the specification requires a number of samples to be taken and tested from each lot. The number of samples required depends on the amount of base course that has been produced in that lot, ranging from 2 samples for a 400 cubic metre lot to 4 samples for 4,000 cubic metres, and an additional sample for every 1,000 cubic metres after that. So you would have to undertake a full range of tests on 6 samples for a lot of 6,000 cubic metres. The last half of TNCDM4 addresses variations in properties of base course from different regions. The requirements of TNCDM4 are changed in some areas to allow local rock to be used, and this section provides amended specification for those different areas. It also addresses the use of melter slag and recycled crushed concrete as base course aggregate. You do not really need to review this half of the specification, although it may be of interest if you are involved in roading in these areas or if you're using these alternative materials. We will now look at the source material and production property tests in a